So we are factoring. Factoring is the reverse process of multiplying polynomials. Here we have a problem we want to factor. If I were to multiply these two pieces together, I would get this piece. What factoring is starting with this piece, getting the pieces, m plus 4 and m plus 3. So reverse multiplying. How do you check factoring? You get your factors and you multiply them. In the binomial case, it would be with FOILing. So the first step whenever you factor is to find a greatest common factor. Look at a problem right down here. What is common to both of these terms? Terms are separated by a plus sign, a minus sign, or an equal sign. So I look at each term and I say, what can I factor out of both? Well, I can factor a y out of both. I can factor a 3 out of both. So I do. I put it here and I see what I have left by doing division. Let's look at problem number 2. I'm going to factor out a 5. I can get a 5 out of each piece. So I do that, and what am I left with? 5's cancel, leaving me x squared. 5 cancel, leaving me minus x. 15 divided by 5 is positive 3. I have factored out a greatest common factor. Now, eventually we will factor that. So go ahead and do number 3 and 4. You can pause the tape or come back to it later. So we're looking at factoring by grouping when we have 4 terms. So not every problem with 4 terms is factorable by grouping, but often it is. So what are we going to do? Number 1, we're going to make groups. We're going to factor out the GCF from each group. So look at one group at a time. What can I factor out of both? I can factor out an x. 1, 2, 3. So I do. What's left? The x's cancel, I'm left with y. The x's cancel, I'm left with z. What about the next side? What can I factor out of both? Well, I can factor out a w. So I do. That's factored. What's left? Y, the w's cancel, and plus z. So there, now what I do, I have one more step. Factor out the common binomial. I'm going to do the same thing I did up here, down here. The common binomial is y plus z. And if I've done it right, it will be the same. It'll be common to both. So I factor it out. Remember when I factor it out, I put it over here to the left. So when I factor it out, what's left? Well, x is left. What's left? Well, w is left. There, you have factored by grouping with 4 terms. There's another problem for you to work out. Let's go to the next page. So we're going to factor a trinomial where a equals 1. That's the big thing. And that's the big point in this section. Here's how we do it. We have 3 terms. We want to break them apart. So the first thing I do is draw 2 sets of parentheses. I'm following the steps. Then I'm going to put x's in them. Now I just have to find the missing pieces. So I find 2 integers whose product is c. c is 5. What multiplies to c but adds to 6, which is b? So I know that 1 and 5 multiply to c and add to b. So once I get the right combination, I put them here. So I've put those pieces there, and now I am done. One more. Let's do number 4. First of all, we always want to put a trinomial in descending order. We have t squared minus 2t minus 15. But you see I have degree 2, degree 1, degree 0. So now I write out this, t. And I think about what multiplies to c, but adds to negative 2. Well, I know that 3 and 5 will multiply to positive 15. I want them to multiply to negative 15, so one of them has to be negative. The larger one will be negative, so that when I add it together, it will be negative 2. So I have plus 3 minus 5. So there is how I factor a trinomial. Okay. So now I'm going to take trinomials of the form what happens when a doesn't equal 1. All right? So an example like this. A is not 1. I can't factor anything out, so I'm stuck with an a that doesn't equal 1. What do? Multiply a times c. We know a is 2, this a is 2, b is 7, and c is 6. A times c is 12. Multiply a times c. Find two integers whose product, who multiply to 12, and whose sum is 7 in this case. So what multiplies to 12 but adds to 7? Well, we could try 1 and 12. Well, that's not going to work. 2 and 6 multiplies to 12, doesn't add to 7. So what about 3 and 4? Well, that works. I've found my factors. Now what do I do with them? So it says use these integers to split the middle term into two separate terms. So I'm going to replace 7y, 2y squared. Instead of putting 7y, I'm going to say plus 3y plus 4y plus 6. And now I'm going to go to the next step. I'm going to continue to factor by grouping. And we remember that factor by grouping says make two groups. Factor out each side. On the left side, what can I factor? I can take out a y, 1, 2, 3. What's left? Well, 2y is left plus 3. What can I factor out of these two terms? I can factor, the most I can factor is a 2. So I write plus 2, 1, 2, 3. What's left? 2y plus 3. I know I've done it right because the binomials match. So with factoring by grouping, now I factor the binomial out of both terms. 2y plus 3, 2y plus 3, and then write it over here. 2y plus 3. Now, what is left? If I divide out the 2y plus 3, I have a y left. If I factor this out, I have a 2 left. And factor by grouping gives me 2 factors. Okay? So that is factor by grouping. I could check it by using FOIL method. First two terms, 2y squared. Outer two terms, 4y. Inner two terms are 3y. I add 4y and 3y, I get 7y. 3 times 2 is 6. If I check it, this is my check. If I check it, I should get what I started with, and I do. All right, so you've got 3 to practice. Difference of squares. All right, this is a special case. You only use it when you have a polynomial with 2 terms that are to be factored, and the middle term is negative. So see, look at that middle term. The middle term is negative, and a squared and b squared are perfect squares, meaning you could take the square root of each of them, well, this would be a minus, and get an integer or a variable. So this would be a, I take the square root, I get a, I take the square root of b squared, and I get b. So this is a special case. Number 1 fits the special case. I have y squared minus 9. It is a subtraction. There are only 2 terms, so I can use this formula right here. So this is the formula. A plus b, a minus b. So a equals the square root of y squared, which is y. B equals the square root of 9. Don't include the negative sign. B is 3. So now I plug it into the formula. My factors are y plus 3 and y minus 3. A plus b, a minus b. So you have several more problems to work on. Remember that sometimes you need to factor out a greatest common factor first. I can take out an 8, and I'm left with x squared minus 1. but I still can factor this using the difference of two squares. This will give me 8 times x plus 1 and x minus 1, because the square root of x squared is x, the square root of 1 is 1. So that's factoring the difference of squares. Moving on. Actually, we're going to stop right there and we'll come back and do a second video. So go ahead and practice the problems that we've talked about.